Hello students, good evening, namaskar all. How are you? Sai Lokesh, good evening. Aditya Banerjee, good evening. So we have started our chapter that name is IP addressing, and 2 lecture is already completed, and this is the 3rd lecture. So what we have studied in the previous lecture, just we will take one recap and then come to the today's session. Okay, good evening Mahalakshmi. So let's continue the IPv4 addressing, the lecture number 3. And yesterday we have completed that, taken the overview of broadcast address. There are 2 type of broadcast address. One is limited, one is directed broadcast address. So what is the use of limited broadcast address? We will see later, and that time you will got to know what is exact use. So leave the limited broadcast address right now. For your exam point of view, the most important is directed broadcast address. For your exam point of view, the most important is directed broadcast address. Whenever question comes in the examination and it is asking about the broadcast address, you have to always give the answer with respect to directed broadcast address. So how directed broadcast address are formed? Keep network ID as it is, put host ID part all one. Keep network ID as it is, put host ID part with all ones, and then directed broadcast address is created. Asha, Madhuri, good evening. Vikas, good evening. Utkash, good evening. And then after that we have seen the topic, that is the network size. It is not a standard word, it is just used by me so that a complete one line statement is replacing by this 2 word. Basically what? The one line is that maximum number of hosts can be in a network. Maximum number of hosts can be in a network. So how many maximum number of hosts can be in a network? It is totally depend on how many maximum host IP can be there. So if y bit host ID, then 2 to the power y IP addresses belongs to a network. If y bit host ID, then 2 to the power y IP addresses belongs to that network. Among them, 2 are reserved as a special IP address. So 2 are not allowed to use as a host IP address, the first and last. So first is become network address to represent the network. Last is become network directed broadcast address. So these 2 are not allowed to use as a host IP. So we have 2 to the power y minus 2 number of IP which can be assigned to a host, and that number of hosts maximally can be in a network. That is the capacity of the network. Fine. We have discussed this also in the class, and there are 2 homework questions. So we have to discuss first 2 homework questions. Fine. And Prashant, Gayatri and Joel. Okay, so today we are going to start the important topic, that is network mask. Basically mask, sometimes it is referred as network mask, and sometimes we can use as a subnet mask. What is the difference between network mask and what is the difference between subnet mask? Why when we are using the term? So better just we are going to discuss about mask. What is a masking process and what is a mask? And then after that, one topic is pending, which we have to cover also. That is part of our syllabus. Although questions are very less in the class full category, maximum questions are come in the classless category on the basic fundamental. So we have to take overview of sorry, we have to take overview of classful IP address, how classes are created in the classful IP category, and we have to discuss about it also. So before starting our topic network mask, let's start with the homework question. Fine. Charan Nayak. Okay, so this is introduction. My name is Abhishek, and that's enough. Come to the this example number 6, which I have give you as a homework question. So I think I do not need to give the time to solve this question. You already solved if you are doing sorry, if you are doing your homework regularly. And then 45 seconds, or I think 30 seconds is sufficient to submit your answer. So submit your answer. 30 seconds is sufficient, I think. What answer you are getting? Submit. So here in this question, basically yesterday we have discussed about it. A classless IPv4 network, the broadcast address, that is a special IPv4 address of this network is this, and the size of network identifier field is 22 bits. The size of network identifier field is 22 bits. Which one of the following can be a network address? That is a special IPv4 address of this network. So yesterday we have seen one example number 5. Yesterday we have seen example number 5 in which network address is given and the number of network ID bits is given, and we have to tell what is the correct broadcast address. Here broadcast address is given, and number of network ID bits are given, and then we have to tell which is the correct network address of this network. Accordingly, here I am writing this number as a broadcast address, and the network ID is 22 bits. If network ID is 22 bits, means you will find out that the network ID and host ID are separated. Network ID and host ID are separated in third octet. Network ID and host ID are separated in third octet. So initial 2 octet, no need to make binary. You just make it 175, and you have to create the binary of last 2 octet only. This 175 and 255, and then accordingly count starting 22 bits. Those are the part of network ID bits. Don't disturb it, keep it as it is, and whatever the last 10 bits. Why 10 bits? 32 minus 22, it's 10. 10 bit is your host ID. The last 10 bit is 0. The last 10 bit is 111, and then accordingly those last 10 bit should be replaced by all 0, 10 0. Then your network address is created. So here basically the network directed broadcast address is given in the question 175, 255, and here I told that don't make binary of first 2 octet, although I created the binary of first 2 octet also, but not required to create binary of first 2 octet, just create binary of last 2 octet. This 175 is this. So what is binary of 175? The binary of 175 is 160 plus 15. What is 160? 101 is 160, and what is 15? 41 is 15. So 1010 is 160, and at last 4 bit 1111 is 15. So 160 plus 15 is become what? 160 plus 15 is become 175. So this is the binary of 175. And what is the binary of 255? All 1. And here we have to count 22 ones. Here we have to count 22 ones. First octet 8 bit, next octet 8 bit, 8 plus 8 16, and the third octet is starting 6 bit. Third octet starting 6 bit is your network ID, and remaining bits is your part of the host ID. So here 8 plus 8 16 plus 6 62, sorry 22. 8 plus 8 16, 16 plus 6 22. So here I am writing these 22 bits is your basically network ID, because it is mentioned in the question network ID field is 22 bit long, and the last how many bits remain? 10. Last octet 8 bit and 2 bit, third octet, second last octet, third octet, last 2 bit. So this is 10 bit. This is 10 bit host ID. And here we have to create network address. So for network address, put all 22-bit network ID as it is. Put all 22-bit network ID as it is. So here this is 22-bit network ID. I am keeping it as it is. I am keeping it as it is. Only this 10-bit host ID for broadcast address, directed broadcast address, this should be all 1. This all 1 is replaced with all 0. So this 10-bit host ID, this 10-bit host ID is replaced with what? This 10-bit host ID is replaced with all 0. And this is the finally network address of the network whose broadcast address is this. Here, what is a binary? What is the decimal number of corresponding this binary? So here 175 is converted in binary, and this binary as it is carrying. So there is no need to draw the binary of first octet. It should be 175. What is the binary of second octet? It is broken in binary, and that binary is as it is carrying and then convert into 175. Second octet is definitely 175. So here no need to convert the binary of first and two octet, first two octet, first and second octet, but I draw. But in exam, no need to draw the binary of first and second octet. You need to draw the binary of third and fourth octet only to save the time in the exam. Now we have to see what the number in the third octet. This binary, you will find out this number is 160. 101 is 160. 128 plus 32. 128 plus 32 is 160. 160 plus this 4-bit number is 1100. 1100 is 12. If you know the hexadecimal number, then 0 to 15 binary you should know. The 12 is 1100. So 8 plus 4 is 12. So this is 12. 160 plus 12, 172. 160 plus 12, 172. And then what is the last octet is all 0. This is 0. So this is the answer of your question. 175, 175, 172.0. 175, 175, 172.0. The correct answer of this question is C. The correct answer of this question is C. So you can see here, as per this question, if 22-bit network ID is mentioned in the question, then answer is C. So 64% people are getting C as an answer, and then 21% people are getting B as an answer. If you are getting B as an answer, means you have considered. If you are getting B as an answer, it means you have considered 20-bit network ID. If you are getting B as an answer, it means you are considering 20-bit network ID. And in question it is mentioned 22-bit network ID. In question it is mentioned 22-bit network ID, and if you are considering by mistake 20-bit network ID, you are getting answer B. So you don't assume by your own what is given in the question, follow it and give the answer accordingly. And then A, so the people are saying that first 2 octet only and last 2 octet are part of host ID. Wrong. So accordingly, these are the top 10 people, those who are submitting the correct answer. These are the names. Fine. So is there any issue with this question? Is there any issue with this question? So is there any issue with this question? So here the network ID is 22-bit. Don't assume by your own don't assume by your own the network ID is 20-bit. In the question it is already mentioned. It is the 22-bit network ID. Clear? So there are some doubt. Now I am going to read it. There are some doubt. Now I am going to read it. So basically here Adit is saying sorry sir, misclicked. Okay, answer is submitted wrongly by you. Okay, C will be the answer. Fine. Ranshu is saying, sir, we are now matched with your teaching style. Please pace up. Okay, you sync with the frequency, so you say that I have to speed up the teaching speed. Okay, fine. Fine. I solved correctly but marked wrong. Okay, no issue. Fine. So let's come to the next homework question. This is the GATE 2015 IIT Kanpur question. I have given you as a homework. Submit your answer This is the integer question, integer type, numerical answer type. 30 seconds is sufficient, I think. You can submit the correct answer. Submit. So this is again become easy question for you if you have seen the complete picture of the yesterday class, like that network address and then first host IP, last host IP and the broadcast address. In this way, then you can easily solve this question. So what is given in this question? What they are asking, in the network this means one IP address is given and this IP address belongs to one of the network. One IP address is given and that IP address belongs to one of the network. See in this question, what is the slash value? 27 means the prefix of that network is 27, means the network ID, we can assume that network ID is 27 bit. And how many bit host ID? 5 bit. How many bit host ID? 5 bit. 32 minus 27, 5 bit host ID. So one thing is clear, that the network ID and host ID is separated in last octet. One thing is clear, the network ID and host ID is separated in last octet. Why? 8 bit, 8 bit, 8 bit. This is 24 bit. 24 bit is gone and this octet is starting 3 bit. This octet is starting 3 bit are counted as a part of network ID. So 5 bit host ID, definitely network ID and host ID are separated in the last octet. One thing is clear. The fourth octet in decimal of the last IP address of the network which can be assigned to a host is. So basically it is saying that the IP address, the last IP address which can be assigned to a host, in that IP address what is the last octet decimal value, we have to give as an answer. So here first we have to find it out, 22 bit network ID. First we have to find it 22, not 22. First we have to find it out 27 bit network ID and then accordingly last 5 bit, that is a host ID, we have to fill it accordingly. So here if you want to save the time in examination, here the 144 is the last octet. Write the binary of last octet is 1001 0000, and in this case you will see first 3 octet is a part of network ID, and these 3 bit is also part of network ID, and accordingly this 5 bit is your host ID. This 5 bit is your host ID, and they are asking about the last octet. They are asking the decimal value of fourth octet of the last IP address which can be assigned to a host. What is our answer? What can be our answer? Our answer should be, we have to keep these 3 bit as it is. And this 5 bit, if I am keeping this 5 bit all 1, it is going to be used as a broadcast address, that directed broadcast address. And the second last number we have to use means the last IP address which can be assigned to a host. So this 5 bit number should be 1 2 3 4 and 0. So in this way you can say that, what, this is 5 bit host ID, and it is filled with all 1 minus 1. This is basically our answer of the question. If you will see what is the decimal value, you can find it out. 144 plus 14, the answer is 158. The answer is 158. Some people are finding trouble to get the answer because here I am trying to solve this question in shortest way. If I saw this question in my exam, I'll solve this question in this way to reduce the time. I'll just write last octet, make the binary, and I'll find out that starting 3 bit is a part of network address. I cannot change it. The last 5 bit is a part of host ID. It is in my control. So I'll keep 3 bit as it is, starting 3 bit 100, and the last 5 bit I'll fill all 1 minus 1 to make the correct answer. If you are finding difficulty, there is a way. The IP address is given in the question, this. Slash 27 means starting 27 bit is your what? Network ID. Here no need to draw the binary of first 3 octet, just need to draw the binary of last octet only. In this way you will find it out. 8 8 16 8 24 plus 3 27. This 27 bit, this is 27 bit network ID, and this is the 5 bit host ID, and we have to play the role, we have to play each and everything in the host ID part only. Last IP address that can be assigned to a host. So put this 27 bit number as it is, put this 27 bit number as it is, that will be used as your network ID, and this 5 bit host ID, this 5 bit host ID we have to fill all 1 minus 1, and accordingly first 3 octet are unchanged, 210 11, the last octet in the decimal 144 plus 14, this is 158, and the correct answer of this question is 158 as I told. So this is the shortest way to solve the question in examination. If you are not finding suitable in the initial level to understand this, then there is a broad way to understand the things. By practicing, you have to come in the shortest way and optimized way to save the time in the examination. Otherwise you will waste more and more time, then you are not going to attend all the questions. So basically you have to always follow optimized approach, not in the begin. Once you will become comfortable, once you become perfect, then you have to apply always shortest approach to give the answer in the examination. So here the correct answer is 158. 69% people are giving correct answer. And what mistake are doing by other people? They are able to understand the question or not? They are able to understand the question or not? Whether IP addresses become heavy for them because their mathematics is not so good, because IP addresses completely depend on how your mathematical aptitude, binary, decimal, because this is a number game. Your number game is good, your mathematics is little bit okay, then you will enjoy this topic and you are finding suitability. If your number and mathematics is not up to that mark, this subject will become trouble for you, because you have to play with the binary and decimal to binary like that. Vijaya is saying question framing is confusing. Okay, means you are not able to get what the actually question is saying. You are not able to decode what they are asking. Means you are saying that the IIT Kanpur is asked this question and you are not able to decode their language, what they are trying to ask. Is it what they are trying to ask? So basically they are just saying that the last IP address which can be assigned to a host, last IP address which can be assigned to a host, in which last octet in the decimal we have to give as an answer. Now understand, now the definition is clear or still not clear? Now the what they are trying to ask, is it clear or now still not clear? So I think now it's clear. So let's move to the next and our today's topic, that is what? Network mask. So this is a very important topic for our exam point of view and knowledge point of view both. So many numericals which comes based on network mask concept, and why we are using network mask. And at the initial I told that there is a application of network address. So what is the application of network address is still pending to tell you. What is the application of network address is still pending. So now you can understand what is the use of network address. Tell me. Bhumika is asking why last bit kept 0. Bhumika, tell me, if I am keeping this all 4 bit, if I am keeping this all 4 bit 111, if I am keeping this all 4-bit, sorry 5-bit, if I am keeping this all 5-bit by 111, it is going to form directed broadcast address. It is going to form directed broadcast address, and they are not asking about directed broadcast address. They are asking about the last IP address. They are asking about last IP address which can be assigned to a host. Which can be assigned to a host. The last IP address which can be assigned to a host. So open the yesterday notes in which you will find out that the directed broadcast address, network directed broadcast address in which host ID, is all one, and the last IP address which can be assigned to a host, in which the host ID portion is all 1 minus 1. Have you checked the yesterday notes? The last IP address is not broadcast address. Last IP address is just -1 in the last octet in the broadcast address, and then you will get last host IP address. So is it clear? Bhumika, your doubt is clear? Why we are keeping this bit 0? Why we are keeping this bit 0? Why we are not keeping this bit 1? Because if I am keeping this one, it become directed broadcast address, and they are not asking about directed broadcast address. They are asking about the IP address. They are asking about IP address, last IP address which can be assigned to a host. Omega, please tell your doubt is clear or not clear, so that I will move then. So I think you can check with the yesterday notes, and then accordingly your doubt will be clear. So come to the network mask side. In the network mask, tell me one thing. One question I am asking to you: is network mask is IP address? Is network mask is IP address? Right? Yes or no? I am asking: is network mask is IP address, or network mask is IP address or not? Network mask is IP address or not? I am just asking to you people. Just give your overview. If you are knowing about the network mask, if you hear the word about network mask, is network mask is IP address or not? So basically, okay, those who are not hearing this word, okay, no issue. Those who have studied in their semester examination, or might be some are repeating the course, so that's why I am just asking. So one thing is clear: network mask is not an IP address. Network mask is not an IP address. It's just a binary string. Although IP address is also binary string, IP address is also a binary string. In every IP address is a 32-bit binary string. Every IP address is a 32-bit binary string, but those 32-bit binary string is treated as a IP address. But remember, network mask is not treated as a IP address. So what is the use of network mask? First understand how to create network mask. First see in this picture, and why we are creating network mask we will see in the next, and how we are going to use network mask we will see in the third slide. So one thing is clear: network mask is not an IP address. It's a tool, or it's a binary string. What is the use of this binary string? So first, how this binary string is created, let's see. Network mask, in short we are writing net mask. Mask word is also famous, mask is also famous, but network mask is, in short, it is writing net mask. Here I am going to write in 32 bits. The network ID field that is X bit long. The network ID field that is X bit long, X bit network ID, you have to fill by all one. Continuous one, starting X bits are 1 of the binary string. Then the host ID part, Y bit host ID, and this Y bit host ID is filled with all 0 bits, and in this way your network mask is created. What required to create network mask? You have to fill network ID part with all 1, and you have to fill host ID part with all 0. How network mask is created? This is a picture, and why we are creating network mask, that is the second slide, second question. So how network mask is created? Just fill the host ID part with all ones, and just fill the sorry, how to create the network mask? Just fill network ID part starting X bit with all 1, network ID part with all 1, and host ID part Y bits, last Y bit fill with 0. Now tell me, do you know about the AND operation, logical AND? Do you know about AND operation? I think you have studied the digital electronics or is going in parallel. So might be you are knowing about AND operation, bitwise AND or bitwise AND. So tell me, A is a bit, A is a bit, and here I am writing A and 1. What is the answer of this? If I am writing A and 1, what is the answer of this? Write over the comment. A and 1, what is the answer of this equation? Write over the comment. If A is a bit, if A is a bit, then what is the answer of this equation? Write over the comment. Some are saying A, some are saying 1. Is there anyone who is saying A complement? Is there anyone who is saying A complement? Is there anyone who is saying 0? So let's try with the variation. If A is 1, 1 and 1, answer is 1. If A is 0, anything in the end is 0, the result is 0. So this is A. This is always A. One thing is clear. Now one more equation. A and 0. Tell me what is the answer of this equation. Tell me what is the answer of this equation. What is the answer of this equation? A and 0. It's a bitwise AND. 2 bits are there and we are doing bitwise AND. So obviously anything is 0 in the AND operation. True and true is become true. Anything is false, the AND operation is always resultant with the false. So 0 is false. So answer is always 0. And here I am actually going to use this property. Here I am actually going to use this property. Let's suppose if I am giving you one IP address, if I am giving you one IP address and saying that this IP address belongs to one of the network, if I am giving you one IP address and saying that this IP address belongs to one of the network, and I say that the network ID bits are this, network ID bits are this. Similarly in this question, if I will say that this IP address is actually belongs to one of the network, this IP address is actually belongs to one of the network. Here I ask that what is the last host IP address that can be assigned to a host of this network, you have calculated accordingly. If I say that this is the IP address and this IP address is belongs to one of the network, the prefix, that network ID part is 27 bit. If I want to know if I want to know the network address, if I want to know the network address of this network, can you able to calculate the network address? Can you able to calculate the network address? If in this question instead of the last host IP address, if I will ask what is the network address of this network, can you able to calculate it? And if yes, then write the answer over the comment. What is the network address of this network? What is the network address of the network in which this host IP belongs? What is the network address of the network in which this IP address belongs? Write the correct network address over the comment. Write correct network address over the comment. If yes, then write correct network address over the comment. So Dheeraj is writing 210.11 and for network address 128. Correct. This 3-bit is a part of network ID. This 3-bit is part of network ID. Keep as it is. This 5-bit host ID is filled with 000. This 5-bit host ID is filled with 000, and accordingly you are able to write the network address of a network in which this IP address is belong. So if I gave you one IP address, you are writing correct, Dheeraj and Arit. So here some people are trying for it, no any issue. So you have to fill the host ID part by all 0. You have to fill host ID part by all 0, and accordingly you will get the Accordingly, you will get the network address of the network in which this IP address belongs. Whenever I gave you one IP address, right, and I say that network ID is this bit, network ID is this bit, can you able to find out the network address from the IP address? Whenever I am giving you one IP address, host IP address, listen, I am giving you host IP address and I am telling that how many bit for network ID. Can you able to create network address? Yes, like the way you are creating here, similarly you can create it. Now here I am interested, we have to do this thing by program. Here I am interested, we have to do this thing in a proper fashion, we have to do this thing why with the help of some program or with the help of some operation. This to perform this operation, the basically network mask is playing a crucial role. See this picture, see this picture. Here one IP address is given, assume that it is a host IP address. This picture is a complete conclusion. Stop writing and see in this slide. Stop writing and see in this slide. Here what is actually going on? Let's suppose one IP address is given, it's a host IP address. Let's suppose one host IP address is given. Pranshu, assume that it's given. Whenever not given, we will discuss another case, that is a different case. Assume that network ID length is given, network ID length is given. Here I am assuming, here I am discussing that one IP address is given and we know that what is the length of network ID part. So we have divided the IP address in network ID and host ID part. We have divided the IP address in two parts, network ID and host ID. We have to create a network mask. To create a network mask, we have to fill starting X bit by 1 and last Y bit by 0. So in this way, network mask is created. The IP address is a combination of two fields, network ID and host ID. The IP address is a combination of two fields, network ID and host ID. Here, the network mask is a combination of two fields, starting X bit followed by Y0. The X is value of network ID bits and Y is a value of host ID bits. And here I am doing bitwise AND operation. Here I am doing bitwise AND operation. So what is bitwise AND operation? Bit by bit we have to apply AND. Whatever this bit, let's suppose this bit is anything. If we are doing bitwise AND by 1, whatever this bit, it is copying as it is. Whatever the second bit, it copies as it is. Third bit copied as it is. Whatever this last bit of the network ID, if I am going to bitwise AND with 1, it is copied as it is. So whenever I am doing bitwise AND with all ones, the resultant number is the same which is given as an input, this one. This network ID is given as an answer. One part is solved. Come to the second part. Whatever the bit of the host ID field, if I am going to bitwise AND, with 0, whatever the number is, it always converted it into 0. Whatever the number is, it always converted into 0. So in this way, this part is done doing bitwise AND with this part, and we are getting network ID as it is. Here, this part is doing bitwise AND. We are doing bitwise AND with this all 0, and the result is all 0 like this. So in this way, you can see here. The basically our IP address, given IP address, and we are doing bitwise AND with the network mask. Here we are doing bitwise AND. And these two binary string are equal in length. This is 32-bit binary string, it's IP address. This is 32-bit binary string, it's not an IP address, it's just a string. And two 32-bit binary string, we are doing bitwise AND. What result we are getting actually? The result we are getting, that is network address of which network? Whose network? The network address of a network in which this IP address belongs. Whenever one IP address is given and we know how many bits for network ID, accordingly we will construct the network mask. And then what we have to do, bitwise AND with this two string, and the resultant is that network address of a network in which this IP address belongs. Network address of a network in which this IP address is belong. So can you able to understand? This is the procedure which we are doing earlier in the question. We are taking X bit network ID and keeping it, and we are filling Y bit with 000. Here I am doing the same. I am keeping X bit as it is. Here I am keeping X bit as it is, and here the Y bit I am going to wrap by 000. I am keeping X bit as it is. Here I am keeping X bit as it is, and the Y bit I am replaced with the all 0. So this is the a process in which host ID is replaced by all 0. This is the process which we can implement in our program. This is the process which we can do implement in our program. So in our computer, one IP address, one mask, and we are getting network address. From IP address, mask, do bitwise, and what you are getting? Network address. So this is a standard way to get network address in a computer, and this method, this process is actually implemented in our computer, and this method and this process is actually implemented in our computer. That's why we always required network mask. That's why we always required network mask. With the help of network mask, we are able to convert IP address into network address. So whenever IP address is given, we have to find it out. This IP address belongs to which network? For example, whenever you will see your bank account number is there. Whenever you will see your bank account number is there, in the bank account number, starting few digits generally representing the branch. Starting few digits are going generally representing the branch code, branch number. So accordingly, whenever I am giving one account number and saying that this account number is belong to, let's suppose one of the bank is State Bank of India or any other bank. So in that bank series, the bank person is going to always check starting few digits. This number is going to belong which branch account number is there. Accordingly, whenever I am giving one IP address and I say that generate network address in which this IP address belong, this is the way. If we are going to write theory for it, basically network mask, basically the network mask is a binary string used to produce network address of an IP address. An IP address belongs to a network, and the network address is produced with the help of this network mask binary string. So this operation we have implemented in the next slide. The IP address, the host IP address, or it can be anything. An IP address is doing bitwise and with the network mask, corresponding network mask. Always use valid network mask. If you are using invalid network mask, then situation will be different. So we will discuss about when valid, when invalid. We will do the case study. So whenever we are doing valid network mask, whenever we are taking valid network mask, it always give correct network address of a network in which this IP address belong. And tell me one thing, the last statement regarding the network mask, then I'll ask any query regarding topic. Tell me one thing, two person having the account in a same bank, same branch, two person having their bank account in same bank, same branch. Tell me, the account number of both the persons are different. Account number of both the persons are different. But tell me, the starting few digit of the account number which is going to represent the branch code, starting few number of the account number is going to represent the branch code. Thus they both are having same branch code in the account number, or they are having different branch code in the account number. Thus they are having same branch code in their account number, or they are having different branch code in their account number. Obviously, if two person are having account in same branch of one bank, and then their account number are different, but starting few digits which is representing the branch code are definitely same. Another example, if this example is little bit heavy for you, the another example is that two person are residing in same city. Two person are residing in same city and they both are having landline connection. Their landline numbers are different, but their STD code must be same. Their landline numbers are different, but their STD codes must be same. They both are residing in same city, means they both are having same STD code. True. Two persons are residing in different city. Two persons are residing in different city. Then definitely their numbers are different. Also their STD codes are different. Why? Because they are residing in different city. So same concept is applied here, and based on this concept questions is asking in the examination. Based on this concept questions are asking in the examination. What is the third line? The third line is that all host, third line is that all host belongs to same network must have same network address. A host belongs to a network. We are going to convert IP address to network address. We will get one network address. The other host belongs to same network, and we are going to convert. We are going to find out network address with the help of this equation. We will definitely get same network address. So all the hosts belongs to a same network. They are having common network address. They are having common network address, and this property is a very important property. Based on this concept questions are asking in the examination. Based on this concepts questions are asking in the examination. So you have to remember this point very carefully. All the host belongs to same network must have same network address. So if I am going to put one IP address and I will get network address, if I am going to put other IP address of the same network, I will definitely get same network address, not different network address. But whenever I will find it out that two host, two IP address belongs to different network, two IP address belongs to different network. If we are doing bitwise AND and then finding out that they are having different network address. So here I am just writing one example. Let's suppose host A and host B are in one network, and host C is in one other network. So in this case what happen? If I am doing IP address of host A and bitwise AND with corresponding net mask, bitwise AND with corresponding net mask, then I will get network address 1. Then I will get network address 1. Similarly, if I am going to check IP address B and I am doing bitwise AND, and same net mask which is used here. How many bit for network ID? It is defined. The same net mask I am going to use here, and after bitwise AND I will get network address 1. Network address 1 means same network address I will get. But here IP address C of host C, I am doing bitwise AND with the same net mask, the X bit net mask, X bit network ID. Then the net mask I am going to do bitwise AND here. I will definitely get different network address. I will definitely get different network address. So this is network address 1. This is a same network address, but this is not a same network address. This must be a different network address. Why? Because here network ID X bit assigned to a network, accordingly network address will be created. Here network ID assigned to this network must be different. Two network are having different network ID. If two network are having different network ID, definitely they are having different network address. So these two IP belongs to same network, but this IP does not belong to the network in which A and B belong. So in this way the questions is going to ask in the examination. So now I am going to move in the numerical side, but before going to numerical side, now I am just asking, is there any query, is there anything pending at your end? Then you can ask. But listen, here we are using the valid network mask, and assume that how many bit for network ID is given. Whenever the number of bits for network ID is not given, what to do in this case we will discuss as a case study in future. but currently we are going straight, and then later we will discuss some exception cases. So here assume that IP address is given in the question, and network ID, size of network ID is given in the question. Accordingly you can create a network mask and you can generate network address. Anirudh is saying, please explain last part again. This picture, basically see, in this case host A having one IP address IPA, host B having one IP address, that is IPB. Whenever we are going to find out the network address in which IP address A belong, what we will do? IP address A bitwise AND with the network mask. We are getting the network address of this network. We are getting network address of this network. Whenever I am going to use IP address of host B, which is belongs to this network, and I am going to do bitwise AND. I am going to do bitwise AND with network mask, X bit network mask, because X bit network ID is there. Then I'll get same network address. Why? Because these two belongs to the same network, and whenever these hosts are belongs to same network, their network ID part is common. Their network ID part is common, only host ID part is different. Their network ID part is common, only host ID part is different. And whenever network ID part is common, so network ID is replaced here, and network ID is keeping here, and the host ID part is replaced with the 000. Host ID part is replaced with 000. So in this way, whenever we will find out that IP address A belong to one network whose network address is this, IP address B belongs to a network whose network address is this, and at end we will find out that these two addresses are same. Why? Because these two belongs to the same network. So if whenever two hosts belongs to the same network, their network address is same. But whenever two hosts are not belong to the same network, then definitely their starting X bit, are not same. This network ID is different. So whenever we are going to check IP address of host C, IPC, it's not Intel penal code, it's IPC, and whenever we are doing bitwise AND with the mask, X bit network mask, and we will find out that a network address in which this host belong, and if these two hosts B and C are belongs to different network, 100% their network address are different. So if network address are same, means they are belong to same network. If network address are not same, they are belong to different network. It's just conclusion. So based on this statement, question is asking in the examination. And why they are asking question on this concept? When I'll show each and every time our routing uses this concept. How? I'll show. Whenever a packet is getting ready in my machine, my computer is going to identify each and every time whether destination IP address is part of our network or not. If destination IP address is part of our network, then we will do local delivery. And whenever destination IP address is not part of our network, then the delivery is done by router. So we have two choice. Either we have to deliver it locally, or we have to deliver the packet through router, and the router will give to ISP, and ISP will give to the bigger ISP, and in this way packet will be routed. So in each and every time, in every computer, this situation is going to check. Whenever a packet is generated by my machine is going to check whether destination IP address is belongs to our own network or not. If destination IP address belongs to own network, means we have to do local delivery, and whenever destination IP address does not belong to own network, the delivery is done by router. So don't worry, there is a complete picture of this scenario when we study ARP protocol, address resolution protocol. In that time I'll show complete picture of this scenario, how source host is going to check whether destination IP address is belong to my own network or not. If not, then what to do? If yes, then what to do? Complete case study we will do. So here I am just telling one word as a conclusive statement. Whatever we are studying here These are using in your machine. Whatever we are studying here, this we are using in our computer, not in every computer. This smart board is also using the same thing, because through Wi-Fi it is connected. Through Wi-Fi it is connected, and the pole is here, na? The pole is here. So this pole is also using the same scenario. Every time it is doing masking and checking, masking and checking. So where this masking and checking process is actually applied, I'll show in the corresponding scenario. But here I am just telling, whatever we are studying, these things are actually we are using in a day-to-day scenario, in a day-to-day life. So where we are using and how we are using exactly, complete picture I'll tell. It will take 1 hour or more than 1 hour to explain. Here I just told one thing. This masking process is always applied. This masking process is always applied. So how this is applied, forget about it. What we have to do, whenever two IP address is given and mask is given, we have to do bitwise and check whether results are same or not. If results are same, these two IP address belongs to same network. If results are not same, these two are belong to different network. Leave it. This is a theory. Let's come to the numerical. When we are playing with the numerical, when we are playing with the numbers, your concept will be clear. You will get more clear over this concept. So come to the numerical side. Is there any doubt? Is there any doubt? So I am just trying to say that whatever we are studying, we are using, and where I'll show in the corresponding scenario. So I am just creating a curiosity. I am just creating a curiosity. These things are we will study in the broad way and detailed way. Okay, Vishwa Nandini is selling, sir, if the network address are same, then should we do the bitwise and for each of the host in a network? Basically in exam, two IP addresses given. In a exam, two IP addresses given and one net mask is given, and they are going to ask, check whether these two belong to same network or not. Check whether these two belong to same network or not. So there is no need to check for all the host IP. If you are having free time, you don't have to do anything, you are not having any pending task, and you are interested to do bitwise on end of the all of the host, then you can enjoy. But no need to do it, just learn the concept. If you are going, if 100 hosts in this network and you are going to end, you are going to do bitwise end for each and every 100 host, you are getting same and same answer every time. You are getting same and same answer every time. Why to waste the time? Just learn the concepts. So come to the numerical side. Come to the numerical side, then things will be more clear to you. Example number 10. First, we are learning how to create network mask. First, we are learning how to create network mask. So this is the question, multiple choice question. Here I am creating timeless poll. Similarly, once you submit your answer, just write over the comment submitted, so that I can got to know if 10-20 people are submitted, then I'll stop the poll accordingly. But do fast. and last 10 seconds. So come to this question. First we are going to discuss about the creation of network mask, how network mask is created. This concept is different, sorry, concept is simple. We have to apply in the form of binary and decimal. What is mentioned here? Consider a classless IPv4 network where the size of network identifier field is 22-bit. Network ID is 22-bit in size. Then out of 32 bits, out of 32 bit, 22 bit is your network ID. Then how many bit remain? 10 bit remain. This is your host ID. And what they are asking, which one of the following is network mask of this network? Which one of the following is the network mask of this network? What we have to do? What we have to do? Write 22 ones followed by 10 0. Write 22 ones followed by 10 0. So here I am just writing 22 ones followed by 10 0. So as per this question, they are asking about mask. So network mask, in short we are telling this is net mask. In short this is telling net mask. So here continuous 22 ones, 8, 8 and then 6. 8 plus 8, 16, 16 plus 6, 22. So this is 22 bit network ID, and this network ID is filled by all ones, because we are going to create network mask. This is just binary string, and this 10 bit, 8 plus 2, 10, this 10 bit is your host ID, and we have to convert into the decimal. First octet, all 8 bit are 1, 255. Second octet, all 8 bit are 1, 255. Third octet, first 6 bit are 1 followed by 2 0. You can convert in the decimal, you will find out that 255 minus 3 is 2 bit, 1 1 is 3. 255 minus 3, that is become 252. That is become 252, and the last bit, last octet 80 is 0. So correct answer of this question is 255, 255, 252.0. 255, 255, 252.0. The correct answer of this question is C. So in this way, here you can find it out. C is the correct answer. 85% people are getting correct answer C. Very good. And here the top 10 people names are this. Fine. So come to the next question. Whenever this question comes in the examination, here I am just writing 1 1 1 1 1 1 like this. Don't waste time on writing 1 1 1 1 1. Why? Because you know that starting 22 bits are 1. You know that starting 22 bits are 1. Means the first two octet, that is 16 bit, 8 bit and 8 bit are 1 1 1. It's obviously it's 255 and 255. It's obviously its first two octet should be 255 and 255. You can see first two octet 255, first two octet 255, first two octet 255. First two octet is 255, 255 in all four options. Why to waste time over it? Why to waste time over it? No need to write 16 ones. No need to write 16 ones. Just waste of time. Skip it. And after 16 ones, 6 more ones will be come in the picture. That will be part of third octet. So start writing 6 1. Start writing 6 1 followed by 10 0. No need to write 10 0. Just write 2 0. No need to write 10 0. Just write 2 0. Why? The 2 0 is a part of third octet, and the last 8 0 is a part of last octet. The last 8 0 is a part of last octet, and we know that all 0 are become 0. So why to waste time over it? 0 0 0 0 0. By initially for doing practicing, it's good. We have to write each and everything. But once after doing practicing and practicing, after doing so many questions, you will become perfect in that at the time of examination. Don't waste time over on first, second and the last octet, you have to spend time over the third octet only. The number third octet will determine which is the correct answer, and you will find out that 61 followed by 20, the number is 252. 61 followed by 20, the number is 252, and then the corresponding you have to give the answer. This is incorrect, this is incorrect, this is incorrect, this is correct. So in this way you can speed the time, you can speed up, you can reduce the time while giving the answer in the examination. But don't worry, you are in the initial phase, beginning phase. Do each and everything step by step, take as much as time you want. Automatically your time will be decreases day by day if you are doing practice. So come to the question next. Example number 11. Example number 11. This is a numerical answer type, and here I am creating a poll. Here I am creating a poll, integer type, again timeless poll. In similar fashion, if you are getting answer, if you submitted your answer, just write submitted. Okay, 10 more seconds. So in this question, another different variety, and this type of questions is already asked in the gate examination, gate history. So consider a classless IPv4 network. The network mask of this network is 255, 255, 248.0. How many maximum number of hosts can be in this network? It is asking about network size. First we have to do what? With the help of network mask, we have to find it out how many bits for host ID. With the help of network mask, we have to find it out how many bits for host ID. Here you will find out that network mask first octet 255 8 bit, next second octet 255 8 bit, 16 bit, fine, 16 ones, and in the third octet you will find out 248. After practicing you will comfortable with the binary. 248 means 5130. 5130. Why 30? Because 255 minus 7, 255 minus 7, 7 is 111. So to write 248, 51 followed by 30, and this is become third octet. In this way you will find out that 81 in the first octet, 81 in the second octet, and 51 in the third octet. 8 plus 8 16 plus 5 21. 21 ones in the network mask. This is going to represent the network part, network ID, 21 bit network ID. When network ID is 21 bit, then how many bit for host ID? Remaining bits 11 bit. 11 bit for host ID. And when you got to know your host ID is 11 bit, it's easy to give the answer of network size, network capacity. So here you can see, here I am writing the binary of 255 all 1, 255 all 1. First 2 octet binary here I am creating, but in examination, as day by day you are practicing and practicing, you will become confident, you will become comfortable. Then at that time you are also doing the same. No, you are not going to generate the binary of first 2 octet. You are just counting 81 81 16 1, and then you will just write the binary. You will write just the binary. You will just write the binary of third octet. The binary of third octet is 248. 248 means 51 followed by 30. And this is wrong. I think this is wrong. Either typing mistake I have done. This should be 1. This should be 1. Typing mistake, mine typing mistake. Which color we have to use? Same, this color. So this bit should be 1. Now it's clear. So 51 followed by 30. 51 followed by 30, and in this case you will find out here to here, here to here, this bit is 1, not 0. Fine. So here 8 plus 8 16, 16 plus 5 21. 21 ones in the network ID part. 21 bit is in your network ID part as per the network mask. And how many bit remain? Obviously you can see this is the 11 0, 8 plus 3 11. So this is 11 bit host ID. This is 11 bit host ID, and accordingly here the number of bit in the host ID field is 11. Then the maximum number of hosts can be in a network. Maximum number of hosts can be in a network 2 to the power y minus 2. That is what? 2 to the power 11 minus 2 hosts in the network. So accordingly you will give the answer 2048 minus 2, that is 2046. 2046 host. The correct answer of this question is 2046. Correct answer of this question is 2046. 2046. 53% people are giving answer 2046. And what other people are getting answer? Is there someone who write 2048? 2048. So these are the people, these are the top 10 people who are giving the correct answer. So in this way, there is a way to ask the question in the subnet mask. Hey, Mahalakshmi is writing 11 as an answer. Vijay is saying I did 7 into 255. 7 into 255 means you are saying that this is 3-bit number. Using 3-bit 7 into 255. I'm not getting how you are getting 7 into 255. Leave. So the 11-bit number is a host ID, and the 11-bit is 2 to the power 11 combination, and 2 to the power 11 combinations are there. Out of them 2 are special IP, first and last. First and last are network address and broadcast address. That cannot be a host IP. So accordingly, this -2. Don't forget to subtract -2 in the final answer. So answer is clear. There is another way to ask the question in this category. They are giving network mask and they are asking how many maximum number of hosts can be in a network. Accordingly, you have to find out number of 0 from the last. You have to find out number of 0 from the last, count the number of 0, that will become your number of bits in the host ID, and accordingly you have to give the answer. So any doubt in this question? I think clear. And now we are moving to the next level in the subnet mask, which is actually asking in the gate. In this type of question is also asking in the gate examination. This example number 10 and this example number is 11 is already asked in the gate examination, such category. Don't worry about it. And there is a one more category, example number 12. There is a one more category, it is saying example number 12, and this is a multiple select question. This is a multiple select question. So here we are solving this question in parallel. Here I am just explaining, and step by step we are doing discussion. Step by step we are doing discussion and just checking which option is correct, which option is incorrect. Let's read this question first. So it is saying that consider two hosts belongs to a classless IPv4 network. The question is saying two hosts belongs to a classless IPv4 network. Fine. The IP addresses of the host are this and this. The IP addresses of host are this and this, and it is already mentioned these two belongs to same network. These two belongs to same network. Which is R can be a network mask of this network. Which is R can be network address of this network. What we have to do? We have to check first option, option A. We have to check first option whether this option A can be a network mask of this network or not. How to check? Do the same process. This IP address bitwise AND with this mask and get the result. This IP address, do the bitwise AND with this mask and get the result, and check whether the network addresses in these two operations, the result of these two operations are same or not. The result of these two operations are same, it means this mask is saying that these two belongs to same network. If a mask is saying these two belong to same network, that mask is a valid mask for that network. If the mask is saying that these two does not belong to same network, that is not a valid mask. The network is not going to use that one. So here we are checking one by one. Let's start with the option A. First we are solving option A, and then we will come to the option B and option C and option D. One by one we are going to verify. So here I am writing the binary of 178, 158, 138 and 118. 178, 158, 138 and 118. Second one 178, 168, 158 and 148. Second one is 178, 168, 158 and 148. What is the first option? The first option is 255000. It is saying that starting 8 bit is your network ID and last 24 bit is your host ID. Let's check with the option A whether what option A is saying. So here I am going bitwise and with 255000 and 255000, and this is related to option A. So see what I am doing here. Here I am doing bitwise and here I am doing bitwise AND operation between these two binary string, this with this, and second one is this with this. So what is the binary of 178? What is the binary of 178? What is the binary of 178? Can you write binary of 178? We have to write the binary of 178 first. We have to do bitwise AND. So 178 is what? 128. Yes, 128 will come. Then 64. No. If we are adding 64, it become 192. No need to put 64. Then 32. Yes, 128 plus 32 become 160. 32 is become 160. Then after 160, if I am going to add 16, 160 plus 16, 176. 160 plus 16, it become 176. And after that, 176 plus 2, 176 plus 2, 0, 0, 1, 0, 0, 0, 1, 0. This is the binary of 178. This is the binary of 178. And now I am going to write the binary of 255. Now I am going to write the binary of 255. What is the binary of 255? The binary of 255 is 1, 2, 3, 4, 5, 6, 7, 8. And here we have to do bitwise AND. Here we have to do bitwise AND. Tell me, what is the result of bitwise AND? So here this one is doing bitwise AND with this one. 1 and 1, result is 1. 0 and 1, result is 0. Bitwise AND. Everything we have to do bitwise AND. 0 and 1, 0. 1 and 1, 1. 1 and 1, 1. 0 and 1, 0. 0 and 1, 0. 1 and 1, 1. 0 and 1, 0. You will see this number and starting number is same. What I told, whenever you are doing bitwise AND with all 1, whatever the first number is comes as it is. Whatever the binary of 178, you will see the binary of 178 is the result 1 0 1 1 0 0 1 0. If you are doing bitwise AND with 1, whatever the initial bit, it comes as it is. So this number is 178. This number is 178. So here 178 bitwise AND with 255, answer is 178. 178 bitwise AND with 255, answer is 178. So one property is clear. One property is clear. What is that? One property is clear. What is that? Whenever we are going to bitwise AND a number with 255, whenever an octet is going bitwise, we are doing bitwise AND with the 255, the same octet will be returned as an answer. So 178 bitwise AND 255, no need to draw the binary. No need to draw the binary. Just write 178 as the answer. Just write 178 as the answer. Just write 178 as the answer. Whenever I am writing 178 bitwise AND 255, not logical AND, bitwise AND. This is a different. AND means integer AND or that bitwise AND. So here bitwise AND we are doing. So if we are doing bitwise AND with the 255, the same number will be written. Fine. Second, here the number is 158. What is the binary of 158? The binary of 158 is basically what? 1001. This number is 144. This number is 144 and 144 plus 14. What is 14? 1110. This number is 14. I am writing directly because I am not going very slow for this. You have to practice about it, how to speed up, how to write binary of 158. So 144, 128 plus 16, 144 plus 14. 14 means 1110. And what is the binary of 0? What is the binary of 0? The binary of 0 is 0 0 0 0 0 0 0 0. And here we are doing bitwise AND. Here we are doing bitwise AND. 1 bitwise AND with 0 0 0 0 0 0 0 0 1 0 0 1 0 0 1 0 0 1 0 0 0 0 0, and this number is basically 0. This number is basically 0. So you will see another property is that whenever I am going to do bitwise end of an octet with a 0, bitwise end of an octet with 0, the resultant octet is 0. So here the bitwise end of 158 with 0. Here I am doing octet by octet, although it's a 32-bit binary string. This is a 32-bit binary string. We can do also this 32-bit binary string is bitwise and with this 32-bit binary string, and what is the resultant 32-bit binary string we are going to write in the decimal. Here I am doing just in this way, part by part, starting 8-bit bitwise and with starting 8-bit, next 8-bit bitwise and with next 8-bit. In this way I am doing bitwise and part by part bitwise and. So here 158 bitwise and with 0, 158 bitwise and with 0, it becomes 0. 138 bitwise and with 0, 0. 118 bitwise and with 0, 0. 168 bitwise and with 0, 0. 158 bitwise and with 0, 0. 148 bitwise and with 0, 0. And you will see this is the option A. You will see basically this is the option A, and as per this we have to check the first IP address bitwise and end with the option A mask. The network address is this, and the second IP address as per the option A mask, the network address is this. And what this network mask is saying, check whether resultant network address is same or not. 178.0.0.0, 178.0.0.0 means the option A network mask is saying these two IP address belongs to same network. Option A network mask is saying that these two IP address, different IP address belongs to same network. Why? Because their starting 8-bit is 178, starting 8-bit is 178, and this mask is going to check starting 8-bit only. This mask is saying that starting 8-bit is network ID and rest are host ID. Host ID can vary, but network ID should not vary. So host ID can be vary, but network ID should be same. So as per this option A, the starting 8-bit 178, starting 8-bit 178, rest 24-bit can be anything, replace with 000, rest 24-bit can be anything, replace with 000. So yes, our option A can be a possible candidate of a network mask of this network. Yes, option A is the possible candidate of a network mask of this network. Which is our can be a network mask of this network? Yes, option A can be network mask of this network because it is saying that yes, these two are belong to same network. Fine, but question is not completed yet. This is a multiple select question. So let me finish this question, then I'll entertain your query. So the second option we are going to check whether this mask can be a possible candidate of network mask or not. The second option we are going to check whether this mask is possible candidate of network mask or not. What to do? Write this IP address 2 times, not this, write this IP address and this IP address, write these two IP address and do bitwise and first with this and this with this, and second this with this. So anything you have to do bitwise and result will be same. This with this and this with this. So here I am writing what? 178, 158, 138, 118 first IP address, second IP address 178, 168, 158, 148. The option B network mask I am using. Option B network mask I am using 255.192.0.0, 255.192.0.0, 255.192.0.0. As per this logic, I can write 178 bitwise and with 255. This is 178. As per this logic, 178 bitwise and with 255. This is 178. As per this logic, 138 bitwise and with 0, 0. As per this logic, 118 bitwise and with 0, 0. As per this logic, 158 bitwise and with 0, 0. 148 bitwise and with 0, 0. Now, what is the value of second octet in this result and what is the value of second octet in this result? That will determine whether this mask can be a network mask of this network or not? If these two values are same, yes, this mask is also saying that these two IP addresses are belong to same network. But if these two octet are not same, then this mask is saying that no, they belong to different network. So let's check regarding this. So here I am going to write the binary of 158 bitwise and with 192. 158 bitwise and with 192. The binary of 158 is written here. The binary of 158 is written here. 1001 11110, and here the binary of 192. The binary of 192. The binary of 192 is 128 plus 64. 128 plus 64. 11 followed by 60. 11 followed by this bit, this bit, this bit, this, and I need to draw little bit refined way. 1 0 0 1 1 1 1 0, and here 1 1 1 2 3 4 5 and 6, and we have to do bitwise AND. Let's check. 1 1 1 0 1 0 0 1 0 0 0 0 0 0. You are getting this number is 128. You are getting this number is 128. This number is 128, and here I have to check for 168. Here I have to check for 168. So here I am just writing here only in a small font 168. What is the binary of 168? The binary of 168 is 160 plus 8. 101 160, and we have to write 8. 1248. 1000 is become 8. What is the binary of 192? Binary of 192 is 11 1 2 3 4 5 6. Doing bitwise AND, and we are checking the results. So here 1 0 0 0 0 0 0 0. This number is 128, and you will find it out. Again 128 comes here, and we will see here the resultant of the first bitwise AND and the result of second bitwise AND are same. Means the second network mask, option B network mask, is saying that yes, these two IP address belongs to same network. Yes, these two IP address belongs to same network. Yes, these two IP address belongs to same network. Fine. So option B can also be a possible candidate of correct answer. Option B is also correct. So this is the option A. This is the option A, and this is regarding the option B. And yes, option B can be our possible candidate of the answer. And here now I am going to check option C. Now I am going to check option C. What to do? Same, write to IP address. This mask bitwise AND with this, bitwise AND with this, and check the result. So here I am doing here 178 bitwise AND, 178 bitwise AND 255. You are getting 178. 178 bitwise AND 255. You are getting 178. See, these two are same IP address. See, these two are same IP address. Only mask is changed as per the option C. As per the option C, this will be 0. This will be 0, and this will be 0, and this will be 0. And then sorry, we have to find what value in the second octet, and we have to find what value at the second octet in these two results. So for this I have to write binary. For this I have to write the binary. So 158. What is the binary of 158? The binary of 158 is 144 plus 14. 144 plus 14 is 158. And what is the binary of 168? What is the binary of 168? The binary of 168 is 160 plus 8. 1000. Here we have to do bitwise and 240. We have to do bitwise and with 240. And this is 1, 2, 3, 4. 240 means 41 followed by 40. 240 means 41 followed by 40. So these 41 followed by 40. And here 41 followed by 40. And we have to do bitwise and we have to do bitwise and so here we can see 1 and 1 is 1. Then 0 and 1, 0, 0, 1, 0, 0, 0, 0. This number is basically 144. This number is basically 144. And here 1, 0, 1, 0, 0, 0, 0, 0. This number is 160. This number is 160. And this number is 144. And this number is 160. So here the option C is saying that these two IP address are belong to different network. This option C mask, the mask in the option C is saying that these two IP address are not part of same network. These are the part of different network. So option C cannot be a possible candidate of the mask of this network because it is saying that they belong to different network. So here option C cannot be our answer. And if option C cannot be our answer, then definitely option D is also not be our answer. Why? I'll just tell, but here I know the shortcut, that's why I'm just telling. If option C cannot be our answer, then option D also should not be our answer, because if answer C is saying that, option C is saying that this mask is saying that these two IP address belongs to different network. These two IP address belongs to different network. Come to the option D. What option D is saying? Here if we are doing bitwise and 178 bitwise and 255, 178, 158 bitwise and 255, 158, 0 and 0. Here 178, here 168, here 0 and 0. And you will see in this picture, as per the option D, these two results, these two network address are not same. So option D is also saying that these two IP address does not belong to same network. But in the question, it is already mentioned that two hosts belongs to same network. Two hosts belong to a classless network and their IP address is this, which can be a network mask of this network. Option A can be a network mask, option B can be a network mask of this network, but C and D cannot be a network mask of this network, because as per this C and D, this should belong to different network, but actually these are belong to same network. So the C and D are telling wrong statement and A or B are telling that correct statement. So this is a basic version, basic way to solve such kind of questions. And why we are doing this, we are just thinking about it and we are doing analyzing about it. But the initial approach, how to solve such questions: two IP address is given, one mask is given, we have to check whether what this mask is telling, whether they belong to same or they belong to different. Two IP address is given, mask is given, we have to check whether what this mask is telling, what this mask is saying, whether they belong to same or whether they belong to different. So in this way, the correct answer of this question is A and B. This is a multiple select question. This is a multiple select question. So the correct answer of this question is A and B. And now you are free to ask your queries. I know so many queries are just waiting in your mind and you are just trying to put over the comment. So now you are allowed. Om is writing one. D can't be answer as 158 and 168 will be different for bitwise AND operation. True. So why I told that if C is not answer then D is not definitely be not our answer. I'll explain about it. Whatever the query you are coming in your mind, whatever the query you are holding it, whatever the query you are waiting, now you can ask if any comes in your mind. So this is the way we are solving such questions, and I am giving two homework question related to this which is asked in the gate history. So two homework questions are there, but before that I am waiting if any query you want to ask. If no, then I'll say few words about this question. So everything clear or any doubt? Everything clear and or doubt or having any doubt? Okay, Vijay is asking, it's taking too long to apply mask each and every time. Is there any shortcut? Yes, Vijay, you will find shortcut, but to find the shortcut, you have to follow the long way first. And this is the long way, longest way. Once you will complete the longest way, and then you will find out that, oh, there is a shortcut way also. Shortcut is always knowing by following the longest way. So once you will complete the long way process, then you will find out what is a shortcut way to get the answer of such questions. Obviously, to take option A and do bitwise and then option B bitwise and option C bitwise and option D bitwise and it's time consuming process. It's definitely time consuming process, right? I'll tell shortcut in the same question only. So if no any query, then for shortcut point of view, I am telling few words here, but I suggest that don't apply this shortcut in the beginning. Once you will become perfect over the topic, then you start applying this shortcut in the test series or like that. But don't apply shortcut in the beginning while learning phase. Getting? Write this binary. Write this binary. Option A, this and this. What is the binary? 178 dot 150. Let's suppose here, instead of writing here, I am writing in the fresh slide. 178, 158, 138, and then 118. And what is second? What is second? Second one is 178, 168, 158, and 148. Is it? Can we write binary of entire number? Can we write binary of entire number? Or I suggest do not write binary of entire number, just write binary of second octet only. Just write binary of second octet only. So here the 178 dot, what is binary of second octet? 158. 158 is what? 1001, 1001, 4 bit 14, 1110, right? And the third octet not required to write in binary, 138 and 118. Here the second IP address 178 dot, what is binary of 168? 101 and then 101 and then the 8, 0 1 1 2 3. 101 0 1 2, this 1 and this bit 0, this bit 0 and this bit 0. Fine. And what is the last number? 158 and 148. Come to the option A. Come to the option A. What option A is saying? What option A is saying? What option A is saying? Option A is saying that check starting 8 bit. Option A is saying check starting 8 bit, whether starting 8 bit are same or not. What we are doing here? Starting 8 bit is same. Starting 8 bit is same in both the IP address. If starting 8 bit is same, means the option A is saying that 8 bit network ID. Option A is saying that 8 bit network ID means you have to check starting 8 bit of the both the IP. If starting 8 bit of both the IP is same, they are belong to same network. And here starting 8 bit of these two IP address are same. So as per option A, they belong to same network. Is this point is clear or not? This point is clear or not? I am asking, as Vijay is saying that please tell the shortest method also. I am not telling shortest method, I am telling concept. And after learning the concept, you will got shortest method automatically. First learn the concept. This network mask is saying that 8 bit network ID and 24 bit host ID. Forget about host ID. Network ID is 8 bit, starting 8 bit. So as per this network mask, we have to check only starting 8 bit. As per this network mask, we have to check starting 8 bit only, and the 8 bit starting are same, first octet only, and it is same. So it is saying that yes, these two IP address have same 8 bit prefix. These two IP address are having same 8 bit prefix, means they, as per me, they are belong to same network when network ID is 8 bit. When network ID is 8 bit, they belong to same network. Fine. Only two people are saying clear, Vikas and Vijaya. What about others? You are not getting, then I will not teach this shortcut way. I will teach the gateway, what to do in examination. This way is the gate exam way. This is the way you can solve the question. Apply the lengthy way, longest way. That is sufficient. So I want to know whether you are understanding or not. Otherwise, I will just pushing the concept. So here the option A is clear. Option A is saying that network ID is 8 bit and this IP address is starting 8 bit and this IP address starting 8 bit are same, means they are belong to same network. They are belong to same network. Come to option B. Option B is saying that in option B, how many bit network ID? In option B, how many bit network ID? In option B, how many bit network ID? As per option B, how many bit network ID? As per option B, how many bit network ID? Option A is saying 8 bit network ID. Option A is saying that 8 bit network ID. Fine. Now come to option B. Option B is saying that how many bit network ID? In option B, how many bit network ID? Option B. Network ID, how many bit? Not D, B, Bombay. B for Bombay. I am not asking about D. I am asking about B. How many ones? How many ones in the mask? How many ones in the mask? Count the number of ones. Count the number of ones in the mask. If you are writing binary, 8 1 in the first octet, 2 1 in the second octet. So it's a 10 1. It's a 10 1. Here 8 bit network ID. Here 10 bit network ID. In network mask, number of ones increases, means network ID is having more bit. Here 8 bit network ID. Here 10 bit network ID. Here 8 bit network ID. Here 10 bit network ID. This mask is saying that please check starting 10 bit of IP addresses. Please check starting 10 bit of IP addresses. Starting 10 bits. If starting 10 bits are same, please check starting 10 bits of IP address If starting 10 bits are same, they belong to same network. If starting 10 bit are not same, they belong to different network. So here in this IP address, starting 8 bit are same. We have to check 9th and 10th bit. We have to check 9th and 10th bit. So 9th and 10th bit is this one. So can I say that starting 10 bits are same of both the IP address? These two IP address have 10-bit prefix. These two IP address have same 10-bit prefix. True or false? These two IP address have same common 10-bit prefix, not 8-bit prefix. Now we are talking about 10-bit prefix. This is talking about 8-bit prefix. This is talking about 10-bit prefix. So are these two IP address have starting 10-bit common? Are these two IP address have starting 10 bits common? Same 10 bits. This is 8 bit, this is 2 bit, 10 to 10 bit. This is 8 bit, this is 2 bit. So check this. Check this. Clear? Not clear. So option B is saying that if their starting 10 bits are same, they belong to same network. Option B is saying that I am the mask of a network. I am the mask of a network where network ID is 10 bit. Option B is saying that I am the mask of a network where network ID is 10 bit. Option A is saying that I am the mask of a network where network ID is 8 bit. I am the mask of a network where network ID is 8 bit. I am the mask of a network where network ID is 10 bit. And if they are starting, it is saying that starting 8 bit is same, they belong to same network. If it is saying that starting 10 bit is same, they belong to same network. And fine, they belong to same network, then this can be a mask of this network. Come to option C. How many ones in this mask? How many ones in this mask? Option C. How many ones in this mask? Number of ones. Count the number of ones. Count the number of ones in this mask. Count the number of ones in this mask. Option C. Count the number of ones. 8 1 in the first octet and 4 1 in the second octet. 8 plus 4, 12 ones. You are writing binary. You are writing binary. You will find 12 ones. Means the option C, the mask in the option C is saying that I am the mask of a network. I am the mask of a network where network ID is 12 bit. I am the mask of a network where network ID is 12 bit. I am the mask of a network where network ID is 12 bit. So if starting 12 bits of these two IP address are same, they belong to same network. If starting 12 bit of these two IP address are not same, they belong to different network. So they are just checking their prefix as per their definition. So here I am going to check starting 12 bit. 8 plus 4. 8 plus 4. This is the 12 bit. Check this 12 bit are same or not. This 12 bit are common or not. This 12 bit till 10 bit. Okay, but the 13th bit and 14th bit are not same. So this 12 bit are not same. So option C says that these two IP address are belongs to different network. Option C says that these two IP address belongs to different network because I am the mask of a network where network ID is 12 bit. I am the mask of a network where network ID is 12 bit. And as per 12 bit definition, these two belongs to different network because their starting 12 bit are not same. Because their starting 12 bits are not same. And the last option D, how many ones in the mask? Option D says that I am the mask of a network where network ID is 16 bit. I am the mask of a network where network ID is 16 bit. I am the mask of a network where network ID is 16 bit, 16 ones. So if these two IP address have starting 16-bit prefix, common prefix, they belong to same network, and they are not having starting 16-bit common prefix, then they are belong to different network. So you will find it out as per this option D. This 16-bit are same or not. When 12-bit not matches, how 16-bit is matches? When 12-bit are not same, how 16-bit are same? When 12 bits are not same, when 12 bits, 13 bit and 14 bits. So when 12 bit mask is saying that no, when 12 bit mask is saying that no, they belong to different network, then how 16 bit mask will say that they belong to same network? When starting 12 bits are not matches, then how starting 16 bits are matches? So that's why when C rejected, he says that no, they belong to different network. They belong to different network. D is also say that definitely they belong to different network, because the 12-bit mask is saying that they belong to different network and I am the 16-bit mask. So I am checking starting 16-bit. I am checking starting 16-bit. When 12-bit says that different, then I will definitely say that different. So here, if 12-bit says that starting 12-bit are not common, then definitely starting 16-bit are also not common. So in this way, option C is rejected, then D is also rejected. Don't waste time over the D. Correct answer is A and B. And to solve this question, what is the optimized approach? To solve this question, what is optimized approach? Always start with the mask which is having highest number of ones. Always start with the mask which is having highest number of ones. So here, check with the option D. Check with the option D. If starting 16 bits are not matches, then check with 12. If 12 bit not matches, then check with 10. If 10 bit is not matches, then check with 8. Let's suppose 16 bit, starting 16 bit not matches, then we have come to the 12 bit. 12 bit is also not matches, then we come to the B, 10 bit. If 10 bit matches, then no need to check for A, automatically tick. When 10 bit are common between them, then 8 bit is definitely common. When 10 bit is common, then 8 bit is definitely common. It's a common aptitude. It's a common aptitude. So the Vijay is asking about the shortest trick. This is the shortest trick. In this cases, write the binary of these IP addresses and check how many bit we have to check in the prefix. How many bit we have to check in the prefix accordingly. So this is the shortest way to solve the question in the examination. But I suggest do not opt shortest trick in the beginning. While studying, while practicing, always follow this long way, this A, B, C, D in this way. Just practice accordingly. Once you become comfortable on IP address, then automatically you come on this phase. Automatically you will come on this phase and applying shortcut trick. Initially, if you are directly applying shortcut trick, you are not getting concept in the perfect way. So here I am giving some homework question. I think what I am trying to say, you are getting. In this question, the network is given. In this question, network is given, but it is not given how many bit in the network ID. It is not given how many bit for network ID, and accordingly 4 masks are given. First mask is according to 8-bit network ID, second mask is according to 10-bit network ID, third mask is according to 12-bit network ID, and the last mask is according to 16-bit network ID. 4 different options are saying that 4 different choice for network ID, and we have to tell according to this scenario which network ID, which bit network ID is suitable. 8-bit, 10-bit is okay, but when you are increasing the network ID, making 12 not suitable, 16 not suitable. So in this way we have to solve the question. Basically this theory behind it, the how many bits of IP address starting bits are common between them, accordingly we have to give the answer. And here our homework question similar to this question which asked in the gate. I says that solve this question in 2 way. One is long way, and then at last you can apply the shortcut. So this is the gate question. A multiple choice question asked in 2010 IIT Guwahati. IIT Guwahati. 2-mark question. Homework question. Homework for you. Clear? Apply the same way. In same way you can solve this question, long way and short way, apply both as a practice. Come to one more question. In 2003, 2-mark question. This is MCQ. 2003 means IIT Madras, IIT Chennai. And in this question, the subnet word is written. Assume that it is a net mask. Assume that it is a net mask and solve it. It is a net mask for a network and then solve it. So interchangeably they are using sometimes net mask, sometimes mask, sometimes subnet mask. So what is the difference? We will discuss in the further classes. But currently you are assuming that it is a net mask and this is the net mask of a network, and then solve this question accordingly. This is a homework question. So these two questions you can solve it via both the method, long way and short way. Optimized method you are also having, but apply before that you have to apply long way then short way, both, so that you can become confident in the both the method. Fine. So here let me check, is there anything pending? No. So here today we have to discuss the classful IP address, but time is not allowing us. We have to stop the today's session. So tomorrow we will discuss first what is the classful IP address. In 30-40 minutes it's completed, and after that we will turn into the subnetting part. But before going to subnetting, we will discuss these two homework questions. So these two homework questions, and then we will discuss about the classful IP address. We will discuss about classful IP address A, B, C, D, E, all 5 classes, and then we will take the lecture into the subnetting part. So starting 1 hour homework question discussion plus classless IP, sorry, classful IP, and then we will come to the subnetting part. So in after 1 hour we will start subnetting tomorrow. So subnetting is also same concept, only you know about the network first, and then we will divide the network into the sub network, smaller network. So division of network we will see later. First go with this concepts. So I think everything is clear. Any doubt is pending, then you can ask. If no any doubt, then I am going to stop today's session. And classful IP address is pending. We are just lagging slightly, no any issue. I'm just putting little bit slow speed because the IP address is important concept. Everyone should catch it because this is a very, very important exam point of view. Clear? So here we have discussed the network mask. One question or two, 3 questions exercise question I discussed. 2 homework questions are there. You have to practice it about detailed discussion. Spend at least 30 minutes in each question. Spend at least 30 minutes in each question, or 15 to 20 minutes at least. Do play with the options and do play with the choices and then binary and all these things, and apply shortcut, long cut, everything. Do the thorough analysis of the questions and then. So okay, thank you everyone. So by the way, you understand what is the concept of net mask. It is just trying to say that check the prefix. How many bit prefix? The number of ones in the mask, that number of bit we have to check is a prefix. Let's suppose the mask is having 10 1, then you have to check 10 bit prefix. If a mask is having 12 ones, then you have to check 12 bit prefix. So mask is basically purpose of checking prefix. Mask is basically purpose of checking prefix. So whatever the bitwise and we are doing, whatever the purpose we are doing, just we are checking prefixes. Just we are checking the prefixes only. If prefixes are same, the result is same. If prefixes are not same, result are not same. Just concept is there. If prefixes are same, we are getting same result. If prefixes are not same, we are getting different result. Just one line conclusion. Clear? Okay, thank you everyone. Might be you are taking exhaustive, take a break. After that one lecture is there, 9:30 digital. Take a sleep. In morning just revise few things. I think morning you are also having class. It's a too much 3 classes, then how you will are getting time to revise. Just steal the time in the classroom, lunch break or tea break, whatever in college hours you can take the time for revision also. Fine. Okay, thank you everyone. Take care. Good night.